All right, our essential question is, what are the angle relationships? And I really should say, what are the basic angle relationships? In the last unit, we talked about, or in the last lesson rather, we talked about single angles. That we classified them. They were acute, obtuse, right, straight, or reflex. We named them, putting the vertex in the middle. We talked about the sides being rays. Now we're going to talk about the relationship between two angles. We're going to learn some, the basic ones in this lesson, and you'll learn even more in Unit 3. Okay, so two angles that are adjacent to each other and that share a common side are called adjacent angles. Now, adjacent means side by side. Okay, Maryland and Virginia are adjacent states. They're touching. You are sitting adjacent to the person next to you. So if we look at this, these are adjacent angles. This angle and this angle, they share a vertex and a common side, making them adjacent. Let's look at another one. Okay, these angles, this one and this one, are adjacent. They share a vertex and a common side. Okay. This one and this one are not adjacent. They do not share a common vertex and side. So that's a non-example of adjacent angles. Vertical angles. Two angles vertical or opposite from each other on intersecting lines. They are always congruent. Now, the symbol for congruent is the tilde over the equal to sign. And congruent means same measure. Okay, same size, same shape, everything's the same about it. So let's look at a couple of vertical angles. We have intersecting lines. This angle and this angle, they're across the X from each other. They're vertical and they are congruent. This angle and this angle are across the X from each other. They are vertical and they are congruent. Let's see, a linear pair. Two angles that are adjacent and supplementary. Okay, if you are adjacent and supplementary, you form a straight line or a straight angle. So what does that look like? Okay, this angle plus this angle has to equal 180 degrees. That's the supplementary part. Any two angles whose sum is 180 degrees is supplementary. Supplementary angles. Okay, so that could be a linear pair. Let's say this is 40 degrees and this is 140 degrees, so that would equal 180. But it doesn't have to be a linear pair. I could have a 90 degree here, and I could have a 90 degree here, and they're still supplementary to each other. So sometimes supplementary angles are adjacent, and sometimes they're not. Linear pairs, on the other hand, have to be adjacent. They have to share a side. Any two angles whose sum is 90 degrees are called complementary. angles. Sometimes they're adjacent. (30°, 60°. Sometimes they're not adjacent. 40°, 50°. Now, sometimes people have a hard time remembering which one is complementary and which one is supplementary. So if we take the first letter of each, it can help us figure it out. If I connect the ends of the S, that makes the 8 in 180. And if I connect the ends in the C, that makes the 9 in 90. It's a little mnemonic or memory trick to help you remember them. Another memory trick, when you do something right, you get a complement. Right angles are 90°, so complementary angles are 90°. Whatever it takes to figure it out. Alrighty, some practice here. Identify the angle relationship and find the missing measures in each figure. All right, so I'm looking at this angle and this angle. They're across the X from each other, so they are vertical angles. Vertical angles are congruent, so X is going to equal 112°. They have the same measure. Okay, looking at our next example, these both add up to 90°. I know that because of my symbol here in the vertex. So X plus 68 will equal 90. X is going to equal 90 minus 68, which is 22°. And that makes these angles complementary. My next set of angles, wow, they make a straight line. Straight line plus their adjacent. The best name here is linear pair. Okay, you could say they're supplementary because they make a straight line. 124 plus X has to equal 180, but supplementary is not the best name. They make a straight line and they're adjacent, so linear pair is the best name. X is going to equal 180° minus 124°. That's 56°. Okay, we've got a couple of things going on here. Goodness, this is the only number I'm given, and it looks like it's opposite or across the X from Y. So Y has to equal 43°, and these two would be vertical angles. X and Y are going to form a straight line. So angle X and angle Y are a linear pair. Which means they're going to add up to 180. So 43 for Y, let's put that in our diagram, plus X equals 180. So X is going to equal 180 minus 43. That's 137°. Let's put that in our diagram. And then X and Z are vertical. Angle X and angle Z are vertical, which means they're congruent. So Z is going to be 137°. There's a lot going on in that diagram, but there's even more going on in the next one. Okay, so let's see here. I know this symbol means this is 90°, so I'm going to label that. And I'm given 72. I'm seeing a straight line here, right? The 90 plus Z plus 72 has to be 180 degrees. These are supplementary. They're not a linear pair. Supplementary angles. And they're not a linear pair because there's 3 of them. Pair means 2. Okay, so Z will be 180 minus 90 minus 72, 18 degrees. You could have also realized that we had complementary angles. Z and 72 have to equal 90 degrees because 90 plus 90 equals 180, but supplementary angles were very useful. All right, so now let's see what I've got here. I'm going to take that off. Looks to me, if I look at the red line and this line, that Y and 72 are vertical. So Y has to equal 72 degrees, and the relationship here is vertical angles. And so that's 72. This was 18. And now Y plus X has to equal 180. So 72 plus X has to equal 180 degrees. This is a linear pair. There's only 2 of them. So 180 minus 72, and X is 108 degrees. A lot going on there. Alrighty, so when I'm given a word problem, make sure you read and draw a picture. I can't tell you how often people just focus on the numbers and they don't actually read the problem. All right, angle 1 and angle 2 are vertical angles. So I'm going to start by drawing vertical angles, 1 and 2. They're across the X from each other. They are opposites. If the measure of angle 1 is 105, so I'm going to label that, what is the measure of angle 2? Well, vertical angles are congruent. So the measure of angle 1 has to equal the measure of angle 2, which is 105 degrees. Angle 1 and angle 2 are complementary. They're going to add up to 90. Let's see, 1 and 2. I'm told that angle 1 is 64 degrees. Find the measure of angle 2. Well, complementary means 90 degrees. So 64 plus the measure of angle 2 will equal 90 degrees. So the measure of angle 2 equals 90 minus 64, which is 26 degrees. Angle 1 and angle 2 form a linear pair. Here we go. Linear pair, 1 and 2. If the measure of angle 1 is 113 degrees, what's the measure of angle 2? Well, linear pairs add up to 180. So the measure of angle 2 plus 113 equals 180. So my measure of angle 2 will equal 180 minus 113, and that is 67 degrees. Okay, so let's see here. Sometimes we have to combine our knowledge of algebra with our knowledge of geometry. And you know these are our favorite problems because we're reviewing your algebra skills. So the measure of PQT, which would be here, is 3x plus 47. And the measure of SQR, which is here, is 6x minus 25. All right, so I'm looking at these, and these are vertical angles, which means they're congruent. They have the same measurement, so I'm going to set these equal to each other. 3x plus 47 has to equal 6x minus 25. Subtract your 6x, negative 3x plus 47 equals negative 25. Subtract the 47. Negative 3x equals negative 25 minus 47, negative 72. Divide by negative 3, and x equals 24. That is not what we're asked for. Find the measure of SQR. So SQR is 6x minus 25, which is 6 times 24 minus 25. So my measure of angle SQR is going to be 6 times 24 minus 25. Love my calculator. 119 degrees. Okay. We tie together geometry, vertical angles, with algebra, solving the equation, substituting. That's a beautiful problem. Let's do another one. All right, AB is perpendicular to CD. That means I've got a right angle right here. DCE is 7x plus 2, and ECB is x plus 8. Okay, so I've got complementary angles, right? DCB has to be 90 degrees. So 7x plus 2 plus x plus 8 has to be 90 degrees. We have complementary angles. All right, so combine like terms. 7x plus x is 8x. 2 plus 8 is 10. Solve your equation. 8x will equal 80. X is going to equal 10. That's not what we're asked for, though. We are asked for the measure of angle DCE. So the measure of angle DCE is 7x plus 2, which will be 7 times 10 plus 2. So the measure of DCE is 72 degrees. Alrighty, take a few minutes to write some guiding questions for the examples and a summary for your basic angle relationships.